Hey everyone, welcome to week 15. This is assignment 24 on what's called the Euclidean algorithm. So let me break down where we're at and what we're doing going forward with this assignment. So it does tie into things that we have done already. So at this point, we have some Camp-Buck conjectures. So hopefully at this point, you've come up with these. If not, it's laid out here in some more mathy terms, but I'll break it down. So the Camp-Buck conjectures are as follows. Given, or if there are integers m and n such that v is equal to ma plus nb, then v is a multiple of the greatest common divisor of a and b. Okay. So what that is saying basically is, okay, if our, in Camp-Buck's talk, our denominations are a and b, then we know that the cheapest item that can be purchased is the greatest common divisor of a and b, right? And then anything that can be purchased at Camp Math is a multiple of that greatest common divisor of a and b. So that's what that one is saying. And also, this is just kind of the converse of it, I guess, the opposite. If v is a multiple of the greatest common divisor of a and b, then there certainly are some integers m and n that this equation is true. In other words, that v can be purchased, right? So if v can be purchased, then we can come up with a method of purchasing it, okay? Okay, and then we have some tools that we've been developing. So here are the three main tools. We have the definition of divides, right? So if A divides B, then there is some Q such that if you multiply by A, you get B. We have the division algorithm, so that if we have any integers A and B, and let's just assume B is the bigger one, or they're equal, then this is true. And we'll put this to some numbers in a minute. And then also we have this shrinking theorem that we developed at the end of the last assignment, and maybe you made that conjecture. If not, it is here. But when you do that shrinking theorem, the remainder is the same greatest common divisor. Well, I guess let's say it this way: the greatest common divisor of A and the remainder is the same as the greatest common divisor of A and B. Okay, so I thought maybe I'll put some numbers to this, right? So it's really focusing on these last two. So let's choose some A and B, and then maybe ones that we have chosen in the past. Or let's just try 24 and 20, right? Let's say that those are your A and your B. Okay, so then if you do 20 into 24, it goes one time with 4 left over, right? So the division algorithm, I would write it like this: 24 is equal to 1 times 20 plus 4, right? That's all identified in this division problem. There's the B, the A, the Q, and the R. Now what the shrinking theorem says is that if I'm trying to think of the GCD of 24 and 20, that's going to equal the GCD of the smaller one, 20, and the new remainder, 4. So it's a way to shrink down the numbers so that you can get the greatest common divisor of two numbers. You could keep doing that process to find the GCD of the original two numbers. And that's what we'll be doing in this section. Okay. Okay. So let's get to some of the problems. And here's an example that I came up with. So the combination of what I just did there, the division algorithm and the shrinking theorem, is known as the Euclidean algorithm. So for example, let's do a new one. Let's see if we can figure out the GCD of 72 and 20. One way to find the GCD, you're just finding the largest number that goes into both of them. So you could just do that trial and error or make a list of divisors, and it's the largest one that's in both lists. But as these numbers get larger, that's a little harder to do, or a little bit more tedious. And so here's a nice algorithmic way, a process to figure out the GCD. So the first step is we're going to divide. 20 goes into 72. And if you want to just use long division on these like this, that would be a fine way to do it, right? But there's the division, right? And so notice where those numbers appear over here, right? We have the B, the A, Q, remainder R, right? And this is a true statement, right? 3 times 20 plus 12 is 72, okay? And so what this means, like previously, the GCD of the original one is the same as the GCD of the smaller number 20 with the new remainder 12. Okay? Now what you're going to do is do the division again with 20 and 12. So now I'm going to do 12 into 20 goes one time with 8 left over. Notice how I've written that there, right? 20 is equal to 1 times 12 plus 8. That shrinks the GCD again. Well, it doesn't shrink the GCD, but it shrinks the numbers. So the original one here, now I go here. And then my new one is the smaller number and my remainder that I just got there. And then you repeat that process, right? So now 12 goes into 8. I won't write it. 8 goes into 12. 8 goes into 12 one time with 4 remainder, right? So 12 is equal to 1 times 8 plus 4. Notice how that shrinks. 12, 8, 12, 8, and then the 8 is the smaller one, the 4 was that new remainder. One more time, 4 goes into 8 2 times with 0 left over. Right, so 2 times 4 plus 0 is 8. So this 8, 4 now shrinks to 4, 0. Once you get to 0, you're done, because the GCD of 4 and 0 is 4. Right, so just choose that number there, and that's your GCD. Thus, the GCD of 72 and 20 is 4. So it's a process to find the greatest common divisor of two numbers without having to list the divisors of the numbers at all. It might take a while, but if you use long division, it's not hard, and it's just writing it out, okay? And again, as these numbers get bigger, this is definitely a preferred method. So the next thing is, can we express the GCD of 72 and 20 as a linear combination of 72 and 20? That is, how would I purchase that $4 item in Campbell's math for find M and N such that this is true? Okay, the method that we can do for that is called unwinding the Euclidean algorithm. And the first step is to do this. So take all of those division algorithms besides the last one. You don't need the one that has the 0 in it. Just the ones where you have remainders that are not 0. And what you do is you rearrange them. So I wrote them there. You're going to rearrange those, solving for the remainder. Just algebraically solving, right? If I solve this equation, I would just bring this to the other side, and then it would be subtraction over there. So that's what's written here. So each of these, you've solved for the remainder. Okay. Once you have that, here's what we're going to do. We're going to start with the bottom one. I wrote it down here. And then we're going to substitute the next one into it. Right? So where the 8 is, I'm going to replace with what 8 equals. So I just rewrote it, but notice here instead of 8 You can highlight it. That is no longer 8, but it's this. Now we're going to do some algebra. Distribute that -1, right? And I just distribute -1 times -1 is +1 right there, right? And now combine like terms. Kind of think of what's inside the parentheses as like a variable. We're not going to touch that. But combining like terms, I can combine the 112 there and 112 there. I get 2 12s. And then the -1 times 20 just stays the same. Okay, and then we're going to continue this. So I have one more to do. 12 is this, right? So notice what we're doing is we're replacing this 12 with what it equals from the division algorithm. And then distribute 2 times -3 is 6, right? And then combine like terms. The ones with the 20s, -6 and -1 is -7. And you can always check it at the end. This should be true, right? 2 times 72 minus 7 times 20 should equal 4. And therefore, the GCD is 4. Okay? So all of that, there's nothing to do in the pages 1 and 2. It's setting you up for what's to come. And then you have some examples to try. So just like I did that example, you have a new one. Find the GCD, right? And then you're going to unwind the GCD to come up with the exchange equation. Right? And then here's another one to try. Same thing. Division algorithm and shrinking theorem. Unwind it to get the exchange equation. And then finally relate it back to Camp Math. So see if you can use what you've learned with those techniques to relate it back to Camp Math. And I think that's the end of this assignment. Okay, and then assignment 25, there's nothing new. It's just more practice. So finding GCDs, relating it to Camp Math problems. So it should be very similar, just extra practice. And believe it or not, that'll be the last assignment of the semester. So hopefully those go well. If you have questions, let me know. And I will be talking to you at another time. Okay, welcome to May. Hope all is well. Talk to you later.